I'm Eric Brynjolfsson. I'm the director of the Initiative on Digital Economy. I think we have almost an exact balance here between Danes and Americans. I was born in Denmark, so I'm not sure which group I should tip the balance towards, but I'm both Danish and American. And I'm very delighted to be able to introduce our first speaker this semester, Mark Gorenberg. I don't know, do you have any Danish heritage?
Actually, we do. It's actually a very funny story. My wife did her genealogy and found out she had 900 years of history of Danish Viking history. So we were supposed to go this summer. We're going to go next year.
All right. Well, I'm sure you can help give you some guidance on that. But Mark is a venture capitalist for over 25 years. He's got a company called Zeta Partners. He's been thinking a lot about this new era of computing, intelligent computing, and how it's affecting the enterprise. So please join me in welcoming Mark Gorenberg.
So first of all, let me thank Eric for the invitation to be here today. I wanted to thank David and Susan and Jovi, well, of course, for their work in helping to get this all going. The Initiative for the Digital Economy has been doing such groundbreaking work. It's really humbling to be here to try to present some concepts, and also an honor, of course, to be here to talk with you about where we see the enterprise evolving. I'm assuming that I do. Oh, I have a clicker.
Right.
Okay, great, terrific. And I'm here accompanied by Ivy Nguyen, who's with our firm. Zeta Venture Partners was the first firm that was started to invest purely in the focus of the intelligent enterprise, which means that we only invest in companies where there's data and algorithms added to software to make the software smarter. And we're investing early stage. We've made 21 investments so far. 2 of our companies have been acquired by Google, one of them being Bebop, which is now Google Cloud, Diane Green's new company. And the other one is a company I'm sure you've heard of called Kaggle, that was written up in both the second machine age and also in machine platform and crowd. It's the largest community of data scientists now, well over 1 million data scientists joining Google. So we have 185 million under management in our second fund, and there's 4 of us that are in the fund. And we started with the premise that said that we've now moved into an age where this is all moved to the enterprise. If you think about this historically, you think about sort of the rise of data that was well documented, let's say in Race Against the Machines. In 2000, we saw the tipping point where there was more digital data than analog data. But what we found most interesting was that by 2005, there was enough data that companies like Google and Amazon were sort of forerunning what we see in this intelligence era. By 2005, Google was starting to make recommendations for how to order their list of SEO, and they were starting to make recommendations of how to do targeting for advertising. Amazon was starting to make recommendations for products, and that was sort of a starting point. And then you saw a litany of a lot of companies in the consumer space that were seeing these network effects. And that's been written up all the way to more modern companies like Uber, Airbnb, Waze, et cetera. But in 2000, we reached this tipping point of data. It was sort of the start, 2010 was sort of the start of the zettabyte era. In fact, we named our firm in 2013 when we started after zettabyte. And there's enough data, and these concepts were now coming over to the enterprise, that we're starting to see this as the decade where we're starting to optimize like the enterprise. And a lot of these same concepts from the consumer companies are now what the enterprise companies are doing. And so from an investor point of view, we're seeing this as the 4th era of enterprise software computing. And by the way, in every era, the group before it became commodity. So when the software era started, hardware effectively became commodity, and workflow software became the value. When the cloud era started, the software that was behind the firewall got relegated more to a system of record, and cloud computing became forward. But what was interesting in the early cloud days, it was much more about the parallelization of hardware and not about the data. Over the last 10 years, a lot of the companies that are selling to the enterprise in the cloud are now starting to generate a lot of data through that system, and they're starting to use that data. And that's giving them a huge advantage, which is what we'll talk about in this talk, in terms of creating intelligent applications. And these applications are starting to make the cloud applications commodity today in the same way that every era before it has done that. And these are the drivers, basically, of that era. So we started by talking about this in the moniker of big data, then analytics, and now, of course, everybody's talking about it in terms of intelligence. Some of the early ones, of course, are very well known. But some of that are more interesting that are leading this transformation is, now open source. Effectively, 90% of code is assembled. It's not written anymore. APIs, which are now the way that software talks to each other or software talks to data. And that's making Lego blocks to pull that together. And Ivy, who was very instrumental in a lot of the work in this presentation, also brought up the idea that we added that all melded process-wise by 2011, where publicly the lean startup methodology started becoming vogue and become very popular. And what that meant was that software could now be created very quickly. In fact, so there was no advantage anymore in terms of features in software. You could basically replicate software in hours or days in terms of your competitors, and you needed to look for new barriers to entry. And so some of those barriers to entry are what we're seeing that are coming through in this analytics wave today. Obviously in IoT, the idea of 50 billion sensors and new advances in image processing, natural language processing. And finally, the idea that algorithms that are used for predictive intelligence are coming into the fore, where just a couple of years ago, predictive analytics was 50-50 at best. Now, typically, we're seeing algorithms that are giving 85 to 90% sort of results in terms of true prediction. And so this wave is now being transformed also by the titans in the industry. If you think about, these are sort of the main companies. They're seeing this as a $1 trillion opportunity to remake the platform of all industries in the next 5 years. And they're spending about 20 to 30 billion collectively right now on R&D to try to move that forward. And they're all approaching it slightly differently. I mean, Amazon is essentially looking at all comers in terms of being sort of the more dominant and certainly the leading force today in terms of cloud computing, certainly the most leading force in terms of what startups are using. Google is seeing this by looking at AI particularly as their cutting edge, where they're coming in and producing much more libraries to be able to empower these next generation of applications. Microsoft is pretty much centered around the enterprise. IBM is a lot of services and of course monitored around Watson. But Baidu is also an interesting company because there's been a huge commitment by the Chinese government. And so they put out a report, just the Chinese government did a month ago, that's looking at the idea of becoming the world leader in artificial intelligence by 2030. And Baidu is obviously one of the main companies there. They're very centered around consumer, something called the Baidu Brain, and very much moving forward in terms of autonomous vehicles and other types of consumer systems. So we're looking at this as twofold in the recreation of the enterprise. One is redefining the enterprise itself, and the other is redefining what startups do in order to sell to the enterprise. We're going to talk about both of those. In terms of redefining the enterprise has to now build intelligent capacity. A lot of it is around data science. And also they need to adopt new applications, which will be relegating the applications that they have to more of a system of record that sits underneath these new engagement applications. And we see this as a transformation in terms of the architecture that enterprises are starting to bring in. So you used to have databases from specific vendors. They were mostly on-premise. Now you're seeing this cloud delivery layer that's becoming more and more used by enterprises. They used to have individual companies that would give them SDKs and middleware. Now a lot of it is services, whether it's APIs or in fact data services that are bringing in that are sitting on top of these cloud layers. The dev tools have changed now to be much more about open source and assembly for software. And then this new category of a whole set of data science tools and the data scientists that use them are coming in. And we'll talk about the applications and how they're moving more to this engagement layer of applications sitting on top of the applications that are here from the cloud systems that are now mostly about offering data. A couple of trends in terms of data that I find really fascinating. One of them is around business optimization. The other one is about data science. In terms of business optimization, what we're finding is that there's a huge number of silos of data throughout the organization. And if you leave them in the silos, your data will be fragmented, and it takes a long time to get answers. So the notion has come forward now of creating the dynamic business cloud in companies. Gartner did a report this year that said if you basically bring all your data forward, if you extract it, combine it, clean it, integrate it, and have it available for learning and for applications that may use it, and certainly for the real-time aspect of looking at it throughout the organization, that you'll improve your ROI by 294%. They surveyed a number of customers. They're starting to implement the idea of a dynamic business cloud that brings all the data together, and also get a 1-month payback. And so this has now become a litany in just the last 2 or 3 years of companies moving from business intelligence to moving to this idea of real-time business optimization. One of the leaders in that space is a company called Domo. They have about 1,300 companies today as customers, some of them throughout large corporations like GE and Cisco, United Health Group. And what's the most interesting about this is that it's also used even at the CEO level. So it's turning everybody in the organization into a data analyst instead of the relegated data analysts that were there during the business intelligence era. And so now a CEO can literally sit there and look at all the key performance indicators on their phone while they're walking around the organization in lockstep in real time with everybody else in their organization. It has the other effect of where before it was people's opinions and people could hide behind what they were doing or not doing. The data doesn't lie. So now you've got the data in front of everybody is what's happening in the organization. It becomes sort of self-regulated in terms of how organizations are managed. In terms of data science, we're starting to see now a number of data science products that are very similar to what software engineers had 25 years ago. So the new field, there aren't tools yet, now they're being created. And the important things of this, and this is a company called Domino Data Lab that is selling to a number of large enterprises. What it has beyond the ability to just keep all the models, it has the ability to version the models, just like software did. It has the ability to create audit trails, just like software had, which becomes very important if you're trying to roll things back, if you're under any sort of sense of compliance in areas like healthcare or finance particularly, and so that you get all that through the system, and that's become important not just to hold the data science models, but also to be able to move these companies forward to start to learn much more about machine learning, because now they have a platform where they can start to work on their models and understand machine learning techniques. And so beyond corporations, also a number of these companies, and Domino's no exception, has created a special group called Domino for Good, and their platform is being sold to universities and nonprofits or being used directly for universities and nonprofits, and a number have signed up. I know Harvard, for example, last month became a user of the Domino product. So this is sort of this new enterprise architecture is sort of what we're seeing in the enterprise evolving pretty quickly. But what's interesting to us as investors is that the whole playbook is changing for startups. And the playbook is changing to create these intelligent apps, which is that they're no longer based purely on the execution software. In the last era, the cloud era, you made the switch from software behind the firewall to software basically that you could run like Salesforce. But it was much more about the execution steps. It was not about the data. And what's happening now in this era is that every single company that we're investing in and everything that we're seeing has effectively 3 layers. It starts with a data layer, it has a decision system layer, and then it has the execution layer. The other thing that's interesting about this is that the execution layer is no longer about the idea of carrying out a number of workflow steps. It's about picking a high-level objective of the company and the data is basically driving what the execution layer does. So and we'll give some examples of what we mean by that. But in terms of the architecture of this, every single one of these companies that has a decision system in it that we're investing in is including this idea that we call the virtuous loop, which is that everyone has, and they call it a different platform within their company, but it's the combination of data and algorithms And so you bring in the data, and that could be public data, it could be crowdsourced data. You run algorithms against that. That cleans the data and gives you a model. And then that clean data is run through new algorithms, and it learns. So basically, the decision system becomes a learning part of the software system. So now you have the data is driving the learning system. The learning system is driving what's happening in the execution, and it's changing the results, and it's changing the results pretty dramatically. In terms of
maybe if you go ahead and give an example of that now.
Okay, all right, great. So let's jump past this in terms of data. We'll come back to it. And all the different software market leaders. So let's talk about a company called Inside Sales. So Inside Sales is a sales acceleration platform, and it has this idea of all the data basically in there. It looks across 3,000 companies today. 3,000 companies are using it, about 100,000 sales reps. And if you think about the network effects of something like Google, now all these sales reps are bringing their data in. And this data is basically driving the system to be able to figure out what is the way to close leads faster. So let me give you and it's running through on that virtuous loop. So let me give you an example of that. So you have 3,000 companies that are using it. A new company joins. You'll send your leads down, and the first thing that they'll figure out is which leads are likely to close, and that's based on looking at the data across 3,000 other companies that they have in a big network system, and the algorithms that they've created to do that. So now you have the benefit of that to figure out which leads are likely to close, and that'll be the first thing that they do. So once that has become basically fairly mature.
And how do they predict which leads? Do they know specifically about that particular person based on the other people,
Yes.
or they know? Okay, so
they have now data on 120 million people, and it's about 100 billion records of data. They have 100 billion records of data that is data around the people, the demographics of the people, the geography of where they live, a lot of data about their companies. And so they're able to pull all that together, look across that, look for similar types of companies. They have a lot of history now of what has closed based on that, and can figure out, okay, if you send me down all these leads are likely to close, these leads are not likely to close. So you start by figuring out where you want to spend your time.
So it basically weights leads.
Correct, as part of it. Okay, the second thing, but because you have this loop, you can do far more than weighting leads. So the next thing you can do out of that, once you've made that mature, the next thing you can do is you can run this loop and say, okay, I'm a company, they started by having a lot of small companies, but then when they got critical mass and this started to work, a lot of enterprises started to become customers. So now an enterprise customer like Groupon, which is a B2C company, or ADP, which is a B2B company, has thousands of sales reps. All those sales reps have information about them as well as the people that they're trying to sell to. So now the next thing you can do is say, okay, which sales rep should I send which leads to, which has the best likelihood to close? And so that's the next feature you might add into the system.
Or create a dynamic bidding process.
Oh, you could do that. And then the next thing that they're doing after that is they're saying, okay, looking across all this data, what time of day would we recommend that sales rep? So now you've got the lead, now you've figured out which sales rep to send it to. Now you're trying to guide them on how to make the close. What time of day should you contact them based on all this information we've seen in the past and we're continuing to accumulate, adding 5 billion records of data a month. So
if one company has some very promising leads, would that sales rep want other sales reps to be able to
no,
go
so I'm not seeing, so they're not sharing leads with other companies. They're not sharing, so let me come back to that. So what they're doing is they're creating a model for you based across the data from 3,000 companies. They're creating a model for you to figure out how to take your leads and how to best close them. And so they're telling you which leads are likely to close, then they're telling you which reps are likely to close them from your company, then they're telling you what time of day you should contact them, then they're telling you whether you should email or call. Then next step is how should you start to message. They call this Neurolytics platform underneath their product. The interesting thing about this is that most of their companies, like in that iceberg example, don't know what's under the execution layer. They don't realize there's this whole Neurolytics process underneath. What they see is they're getting an improvement of 30% better conversions of sales from their leads because they're going through that whole process to figure that out. And you can only do that because of the massive amount of data that has been that's part of the system. Very similar to, frankly, what a Google or an Amazon would do with all the data they have and figuring out how to target consumers. And so the other part about that is that, which is really important in this era, is that they have data rights. So they've signed up every one of their customers, they have data usage rights. And I bring that up because in the previous era, in the start of the cloud era, people purposely did not get data rights. In fact, people were afraid to move to the cloud. So the early cloud vendors wanted to give an indication to the customers that they should feel very safe in moving to the cloud. So the early players that were in sales didn't get data rights. So they can't do any of these network effects. And so that's your leapfrog that's happening from era to era, is signing up use of the data, getting data rights, is allowing you now to jump past the companies that were there in the cloud. And so the recognition of this, for example, is inside sales has been invested in by both Salesforce and Microsoft. And Salesforce now is looking at a product called Einstein that they put forward, but they don't have data rights. So Einstein is purely doing this based on the data of that one company and not the data across 3,000 companies. And the effects of having all that data to analyze versus the data just in your own database makes a huge difference in ROI. And so what's happening now is that these are the generations of companies that are moving up into the engagement layer and being used as the new intelligent applications by enterprises. And the existing companies are being moved down to system of records and basically sending data up into them. And so if you look at that, so crowdsourcing has become an important way to get data. Other ways that people are getting data to make these large databases, they're sending things out like surveys. They're getting data that way. The early companies started with just public data. There was a company that did this in agriculture called Climate Corp, sold to Monsanto for $1 billion. All they had was public data, but it was so early in getting data algorithms to work that they had a huge lead.
So just the real world case on this, I think LinkedIn lost the Washington screen. So a variant for this sales acceleration company could be somebody does a scrape of LinkedIn so as to improve the weight for particular individuals because they either the social graph shows there's a connection there, but somebody has an expertise which would weight you to say they'd be more susceptible to this kind of image versus that kind of image.
That's right. That's right. But you have to be careful in terms of who you're working with and how you're getting the data rights to be able to do that. There are a number of companies now that are supplying that data. Clearbit is an example, but there's dozens of them that are supplying data that you can get, and they're scraping it, basically.
And your company, the systems integrated for that, or you client companies do that and plug it in?
We're investors in some of the companies that are going around the web to get data that you can add, but there are a number of other companies as well. But all these companies typically start with the crowdsourced data that they get through their customers, machine-generated data as part of the process that their customers are producing, in the same way that consumer companies did that in the last era before. I'll give you another example. Another example of that is a company called Marketing Evolution. So Marketing Evolution now has data on 320 million people. They also have hundreds of billions of records of data. And they're in this idea of omni-channel media mix. So there are a number of companies in the cloud era that would basically create a media model for you, and you could run it. You would set it up at the beginning of the quarter. It would be your static model. It would tell you how much to spend on broadcast TV and how much to spend on digital, how much to spend on print, et cetera, and tell you where to target it as well. But it was a static model. They didn't have the data. The interesting thing about these companies is that in this intelligent era is that they can do everything in real time with that data in the same way the consumer companies do. They also, if they have enough data, they can be very granular in terms of how they target in the same way that consumer companies did. So in the case of inside sales, they can target down to the individual. In the case of Marketing Evolution, they can target marketing down to the individual. Not just display, but things like TV through cable, et cetera, and they can run a media mix model in real time. So it's that hundreds of billions of records of data that allow you to analyze that, bring it through the decision system. They also have a virtuous loop as part of their product that's running algorithms and models. And that's then sending up data to say, change your media mix today. Change how you're targeting people today. They're also getting about 30% improvement over the existing models that people are using from the cloud. That people like Citibank spend $1 million on previous vendors that are now adding this on top of those vendors. So Citibank, Best Buy, Fox, Cox. What I'm most proud of is they just signed up IBM Watson as a customer. So they're the marketing arm, using AI as marketing arm of IBM Watson's advertising. Another company is in the retail space that's called Constructor. It's a company actually that Ivy was instrumental in bringing into our firm. And Constructor does auto-suggest. Basically, it's site search. But that auto-suggest, you can use that to figure out what products to send back up to somebody who's looking at an internal site. What's interesting about it, by having all the data, again, having data rights, network data rights across these customers, is that they get lift of 2 to 21% in terms of sales that the company is making by adding site search. But on top of that, beyond giving you sort of better search, they also now can intercept that and figure out which products they want to sell to you based on something being very close to what you made a suggestion about. So they not only can do the search part in a dumb way, they can do the search part in a very smart way by reordering how you're going to see the products. And so these are examples of 3 enterprise companies. We call these enterprise AI-enhanced companies because these companies work perfectly fine in the last era. They just didn't get as good a results. So effectively, these companies that are coming in this era are replacing software with more software. And every line of business, that was the slide we jumped over, every line of business is going to have AI-enhanced software that's going to jump over the generation before by using data. But the next wave is going to be software that's AI-centric. And this is software that this is software where there was no software to replace. What you're replacing or augmenting are humans and doing the tasks that they would do. So, for example, investors in a company called Tractable, which is doing auto insurance claims. They're effectively displacing augmenting insurance claims assessors. The difference in these models versus the AI-enhanced ones, they work right out of the box. They'll work as you add data. There isn't a minimal threshold that you have to get over to get them working, because they're basically starting with where the software was, and they're making the software better and better as it learns. But these companies that are AI-centric need a minimum amount of data to be able to start to do things nearly as well as a human can do that. So in Tractable's case, they worked for about a year gathering data, mostly images, millions of images of car accidents. And from that, they were first able to figure out whether they were able to audit what an insurance claim did, to say, yes, that's probably right. Now they're able to actually create the bill of material directly. So instead of having an insurance assessor have to go out to see an accident, they can basically bring all that in and automatically bring it into the insurance company. And it's based on walking through the steps of the virtuous loop. In their case, it's much more about deep learning than machine learning as part of the loop, because they're looking at tons of imaging and the data is driving it. But now they're seeing results up to that level of a human being in doing that, and so that's much faster in terms of labeling the data to be able to use it. And so as they're adding more data, they're getting better and better in terms of figuring that out. And it's easy to look at parts, straight parts, and try to figure out where they are. It's very difficult to look at mangled parts in an accident and figure out what they really are. And that's where the machine learning and deep learning really is helpful here. So that's an example of one in this AI-centric case. Another one is a company in language translation. It's called Lil. They're doing language translation pairs. They have about 12 languages, so they translate back and forth to English. And they do it, their advantage is that they have a human in the loop as part of this virtuous loop that's helping to make the translation better and better. So their goal, and they started by experts out of Google and out of Stanford, their goal is to be able to make something that is as good a quality as a language translation house, but as good a speed as, say, Google Translate. And right now, their quality is almost as good as a language translation house, and they're about 3 times faster than a language translation house. So this is industrial strength language translation that's coming out of this, and it's done with a very different attack than, say, Google would do with Google language translation, or that Fluent would do. Let's say Lionbridge would do with GeoFluent, which is doing it much more about just here's a lot of general information from documents. Let's see if that makes sense. Here, they start with a number of public documents, and then they have all the information that comes out of the system running in the virtuous loop, and then they have humans come in and do the corrections, and those corrections are making the difference. And so they have a huge amount of data that they've built up that way as well, and a number of tests have been run to show how that works. And they're basically displacing language translators or augmenting them. In the IoT field, we think that the whole idea of AI-centric is going to be really a prolific thing. And Falconry is a case of a company that started by gathering data around production lines. And so there are zillions of sensors on production lines, and they all have streams of data. Well, it takes a long time for a stream of data to be able to trip over a rules-based system to say that there's an error. But you can start to see the variations that are happening before that to get a clue and predict that something bad is going to happen. And so what they were able to do in some of their customers early was take all this data about the sensors and the streams and predict out that a production line would fail. And one of their customers, Jenna, which is a mining company, they were able to tell them 12 hours in advance that the production line was going to fail. And it was based on how the material on the production line was starting to change, not any sensors in the production line. So the ramifications of having a predictive system like this, an AI-centric system like this, is that very small variations in yield, by being able to either run the production line faster because you have a better sense of where it's heading, or stopping outages on the production line. I mean, 2 to 5% change of some of these production lines means $10 to $100 million of revenue increase to companies. So these are fairly sizable things, and they're talking to a number of companies now in oil and gas and semiconductor and automotive about that. And there's no software that's doing this today. So what they're doing is they're really augmenting or replacing production engineers. And frankly, the issue with this is that production engineers who know how to do this are all retiring.
Isn't this what Splunk was supposed to do?
Well, Splunk was more about DevOps, right, initially, rather than manufacturing production. But they were behind the firewall. They're not bringing the data together. So yes, in fact, that's actually a good example of Splunk would be the previous generation of company that didn't have the data network effects. And now you have the data network effects that's coming in from companies like this that's getting much better results.
So this company has the same kind of data rights across production.
Right. So, and more importantly, the machine-generated data, the rights to that. So if you look at all of the companies we've talked about, they all have data usage rights. And it's very important in their context, because that is the difference of whether these companies will be successful or whether they won't have the data to be successful. What's interesting is that the big companies are very happy to hand over data for use because of the outcomes that they get, which are much better without using the product.
This situation, how useful is it one plant or another production plant? Do you have any?
Yeah, it is very useful, because really what you're looking at are the different sensors. So, you know, these sensors are all, common sensors are being used in different sort of production lines, and particularly within the same company. So, you know, the starting point is you get it to work for one production line, and you don't need nearly as much data to get started here, because you have the time series produces a lot of data per sensor. So instead of the examples we showed for you know, images for car auto accidents or for language translation, where you need millions and millions of pieces of data to get started, here, because of the time series data being so prolific per sensor, you don't need that much to get started. So you can get going with one production line. You can then move to network effects of multiple production lines within the same company where they use commonalities. And then if the sensors are the same, certainly will work across multiple customers. So the same network effects will come into play here.
So a client of these companies pays in two ways, basically. They pay with cash, and they also pay by sharing some of their data.
Mhm.
Is that a good way to think about it?
Yeah, it's a good way to think about it.
And are there discussions, negotiations about changing the balance? I mean, there are some who would say, look, we'd love to just pay you cash and not share our data because we want to hang on to it, and then does the vendor say that's not something we do? Or conversely, do they say, look, we've got this incredible data, we think you should pay us?
So it doesn't really, so that would be logical, but doesn't really play out that way from what we've seen. What it usually plays out with is we need to have usage rights to the data to make this work. Are you interested in the results? And then there's a negotiation over the price of the product. So you may argue, hey, you have these customers, they're not as interesting to you in terms of the data. We can really help your data set. We should get a bigger discount in terms of buying, buying the software. But companies like Inside Sales have turned customers down if they're not willing to give them the data rights. So the balance of power, I think, has started to shift because of the results, at least for the early players in the market. And by the way, Eric, it's interesting. There are a number of papers. I read one just this last week on data rights in some of the industries, and some of the more forward-thinking companies are being much more prolific or demanding about this. So, for example, Tesla in the automotive industry, Tesla's contracts for data rights are much more stringent than Ford's. So Ford will basically say, well, I'll let you opt out except for things that are not that critical to driving the car, the health checks and things like that. If you don't want to hand your data to Ford, just don't run the application that tells you kind of the health check of your car. Tesla's contracts are much more about things that are pretty vital for the car. So you're basically going to give data rights to Tesla for your use if you're, if you want to actually make the car operate. And I think that's how the newer vendors in all these fields are able to have an advantage to being able to have the lever of power to get those data rights. And most of the time, by the way, the people part is anonymized because you don't really need to know who the individuals are. It's much more about the machine-generated data to be able to inform the algorithms, and some parts of the actual data that can be anonymized and aggregated. And once things are aggregated, pretty much the contracts say that this data is now in use by the company that's using it.
Can they truly be kept anonymous, though? Isn't it pretty easy to back out individuals once you have enough data? That is a topic that a lot of data privacy people talk about. So I won't weigh into that, but I know there's a lot of reports on it that say that it's very difficult to anonymize data for the long haul. I agree with you on that. So they're basically labeling this data as it comes through as the other systems do. So these were five rules that basically, that Ivy's been working on for the last couple weeks. And I was going to talk about this, but I don't know. I hate to put you on the spot, but I don't know if you want to talk about it. No? All right. Okay. All right. Well, I'll let you weigh in when they get to Q&A. But she had this notion that said if you look across these companies, you start to form some rules about these AI companies. And we came up with these five. And you see through the examples we talked about, the first one is there's this notion of a minimal viable product. And so that with the lean software methodology, people come up with a minimal viable product, they put it in the market, they start to generate some data that informs the system. So we've added the notion that says that you not only have to define your minimal valuable product, you have to denote what your minimal algorithm performance needs to be to make it viable, which means it starts to inform you on what type of data you need and how to go out getting that data, whether it's crowdsourced data, public data, data that you purchased, data that comes from the system of record, whatever that is. And that puts you on the board basically to start getting results for that, whether it's AI enhanced, the ones that were replacing existing software, or whether it's AI centric, which is replacing basically the tasks that people are doing. And the next step is to race to get critical mass of usable data, because the winners and the losers in this space, it's not just the amount of data, but having the right data. The winners and losers in the space are going to be the ones that figure out what data to amass and how to build that data moat, and then be able to analyze it for the features that we talked about in some of these other companies.
and to have the software to be reliable and be able to clean that data in a number of ways for its usage. The third one is to choose the right entry point for products. What you'll see is that some of these, as you add more data, they really expand in terms of their value, and some of them don't. And so understanding that and picking the right entry point to get started becomes also important in terms of choosing your minimal viable product and choosing the data that you have. And then the fourth one is this notion that as your loop is running, the amount of data, it's going to go from getting great returns to starting to slow down, sort of, diminishing returns. It used to be that companies would add features by workflow features. You'd have a product manager, that product manager would figure out what goes in the product next, they put the next release out, et cetera. It had nothing to do with data. Now we believe in this era, all the product features are going to be driven by your data, what data you can get, and what you can do with that data. So I'll go back to the inside sales example we talked about. So they had enough data initially to figure out which leads would close. Then they got more data to figure out which sales reps to send them to. Then they got more data to figure out what time of day, basically, to contact people. Those became the features of the system. It was not over the workflow components. The other thing about that is an interesting epiphany is that it breaks down the silos of the organization. So a sales system before would have, marketing people would go get leads, and then they would qualify the leads, and then they would take the qualified leads and they'd send them over to sales ops, and sales ops would send them over to the sales rep, and then eventually they'd look through their reports and say, okay, here's how it's going to close, and here's where it is in the sales cycle, and we'll give it 10% chance of closing, or now it's 90%, it's going through this. You don't do that with these. You basically start with the objective function that says, we want to close the lead. And now we look at the history of 100 billion records of data to say, how did leads close?
So you're killing the funnel.
We're killing the funnel and replacing it with data analysis, replacing it with algorithms, and lots of useful data. And so once you get diminishing returns on a certain feature, figure out what data you need, move on to the next feature.
I think the diminishing return of inside sales is still in the top of the funnel, right? So as you scroll the funnel, but inside sales doesn't help you build the top of it.
No, but there's
find some other methodology to build the top of it.
Agreed, David. There's a zillion vendors that will do lead gen. You can, and that's from in-person lead gen to computer-oriented lead gen to social systems. So they're not getting into that market. It actually says, okay, how do I fill my funnel with leads, whether they're qualified or not? Somebody else is doing that for those customers. And then the last one, which we think is seminal, is that companies to succeed in this era have to maintain data rights. And that's the only way you're going to secure leadership. And I would make the argument that data rights are the new IP rights. And if you think about this from 25 years ago, it was very unclear that software companies would say, well, we own the IP, and their customers would say, well, no, you don't. And then they would say, okay, well, here's a contract. We own the IP. We're shipping you software, but we own the IP. Now you're seeing those contracts by all these vendors going to talk to their customers about the data. And so this is becoming the new IP right now. I would argue that, so everything we invest in has to have data rights. I would argue that 5 years from now, all other venture capitalists will fall into this bucket of starting to understand this and do this. And I would argue that 5 to 10 years from now, companies, when they go to acquire companies for their value, will look through their data rights contracts the same way they look at their IP rights contracts today to make sure they own everything that they're buying as part of the process. The other thing is that you talk about in the second machine.
Do you aim for one set of exclusive data rights, or is it so lots of companies will want to have the same data?
Right. As long as you have data usage rights, it's usually okay. If you get exclusive rights, even better, but most people won't handle that. And it's not really necessary to make models work. And particularly the most important thing in the model is to make sure that you have ownership to the machine-generated data, not the actual record data that's in the database. So what you talked about in the second machine age, there's a full chapter in there on winner take most market, or I think it was called winner take all. It was very common in the consumer era. It has not happened before in the enterprise era. We believe this notion of adding data and people centered around data is going to change that. That now we'll start to see these enterprise players, because of the data that they've created, we start to move into this idea of winner take most. And enterprise companies have not done this yet. So candidates like inside sales and marketing evolution have a chance because they have hundreds of billions of records of data of data today and a huge lead. But I think we'll start to see this also permeate enterprise very first over the next 5 to 10 years. And this was an insight that in a collaboration that Ivy and I talked about, which is the other thing is that if you look at how AI is permeating through, it's really not permeating because of the technology anymore. It's really permeating because of the risk involved. And I'll explain what that means. So the very first use of it, we talked about in consumer, which really started around 2005, there isn't much risk to putting an AI loop into a consumer product. So maybe I don't like the recommendations that it gives me, or maybe I don't like the order of the search that it came back with. But there's no real downside risk to society. As you move through these, the AI-enhanced applications, there's also very little risk because that process already exists. They might be getting me better return on investment, but it's not going to affect society. It's just going to affect whether I have more revenue or not for my company. AI-centric applications, the ones that are replacing humans, now you're starting to take risk on in society, and society has to choose which ones of these we're willing to take on and which ones we're not willing to take on in terms of replacing people with AI. And then we believe there's a next set of applications that are now being started on today, which are in fields like healthcare and health of the planet. And those will have very high risks involved. And actually, the risk to use them will become the dominant feature, and it won't be the technology impediment. It'll be whether society is willing to take these applications on, and this is kind of a litany of some of the ones that we'll see through that. Examples of those. So we have a company that's now sort of in this next wave of in the health of the planet. You have areas like agriculture, energy, environment, water. This is a company called Nvidia that's using all these techniques around the idea of improving the operation of the electric grid. So what they do is they have a very intricate model of the electric grid in 4 ISO communities, large areas through North America. And they model the electric grid out. And from that, they are able to they're able to predict a better demand curve of what's going to happen that day than any of the utilities currently are doing, again, by using machine learning and deep learning as part of this data. And so they have created a virtual utility. And that virtual utility bids to the ISO every day to win the contracts of what the demand curve is really going to look like and what energy is going to be required to do that. And they are paid in basically ISO credits. So if you guess incorrectly, you'll be penalized as a utility. But if you guess better than the market, you'll get credits from the ISO. So they're getting a lot of money in terms of credits by creating a virtual utility that's using machine learning to create a better demand curve. And then someone else.
It's like an LSI, a large systems integrator, you bid based on the thing, and then you outsource to the individual utilities and power generators for the load management efficiency.
Yes, the ISOs do that.
A layer above the entire system.
Yes, the ISOs do that. But you're basically bidding and giving an idea of how you would do that, run that energy for the day. So you can do it in a much more efficient way. In fact, so they've now been running. They have now billions of records of data, but they've now been running this where they're now seeing almost a 2% improvement in the efficiency of the electric grid when they bid. And the thing that's interesting about it is every year it's been going up 3 times better than the year before. And 2% improvement in electric grid operation is huge number of savings. It's also a huge amount of savings of CO2 that's going into the atmosphere. So this is up and operating. It started with engineers that were out of Cambridge, and the company is actually centered in Canada, and they're using Monte Carlo simulations as part of that.
Are they using ISO data?
Yeah, so they have a lot of ISO data, and they have a lot of NOAA data from the looking at the data of the weather that day and other operations that day.
So here we are, we're in Texas.
Yeah.
We have an extreme event, and does the system collect extreme events?
I don't know, but the weather data and the predicted weather data will give you some ideas of how to put it into your model. But it's an interesting question to see if they had been bidding there, how many hurricanes had they seen before to understand, you know. So yes, it learns over time to figure out what to do. One of the, in terms of health plan, I think that, you know, we talk a lot about the notion of work and whether AI is going to take away jobs or whether it's going to create jobs. And so one of the things that people are most fearful about are autonomous vehicles. But I would actually argue that autonomous vehicles are going to open 31% of downtowns are taken up for parking. And so once those autonomous vehicles come in and you can get a lot more of that space back, you can recreate entire cities, and there's going to be a huge change in that. This is going to be a very complicated AI system because to recreate a city, you're talking about many different, disciplines, from transportation to energy to building and housing to water, downtown agriculture now, downtown manufacturing, et cetera, all into a system with data and sensors. And in the end, it will be done in very much of a similar fashion to what we saw, but with many different disciplines coming together. Another one is the notion of human health. There's a lot of work going on in joining, particularly in universities, in joining AI together with bioengineering in terms of a discipline. It's very early, but to follow the example of what we're talking about in the risk curves, we've seen two companies in the last month, and what's interesting about them is that the first company, which is 3 MIT alumni that are using mimic data that comes out of CSAIL, which is 15 years of ICU data that was at Beth Israel Hospital. They're able to do that and figure out 6 months in advance whether a kidney's going to fail. You would think that's an amazing thing. And the technology works. But here's where the risk of society cuts in. So no one is willing to basically use that today to say that should be used as the gospel of whether or not a patient should be diagnosed by a computer to do that. More interestingly is they haven't found a hospital yet that's willing to say that a doctor should even be informed by that, because it will influence basically their diagnosis as a doctor. Where they are today is that they found hospitals that are willing to take that on to schedule patients. So if you think about this, they're at that point that's kind of like where the sales rep is, where they say, okay, we'll give you the lead, but we won't tell you any more than that. You go figure out what to do. So at least the use today by societal risk is it's scheduling patients based on the system at certain hospitals to figure out what order to see them in. And at least then the patients that may be at the most risk might be seen earlier for kidney failure. Another company that we saw recently is doing liquid biopsy. And they're able to, you know, if you're doing cancer treatment, in their case it was colorectal cancer, normally you would go through a long chemo process. In that chemo process, you would also get, you would also get biopsies every few weeks. Well, what if, in this case you can today, what if you do a liquid biopsy where you get small blood draws basically every day, and based on that, you can run that through all these algorithms, and you can figure out you don't need to do the rest of that chemo treatment, or you should go into a different regimen. The technology is there today to do that. The question is anybody willing to use that and stop their chemo treatment based on a prediction? So this is basically where we see this going, and I'll wrap up with the new paradigms and just basically in summary. So basically in summary, we think we're at a fourth era of enterprise computing today. We talked well about that basically cloud-based computing without data and algorithms has already become a commodity. These consumer innovations that we talked about, that are talked about well in the books that have come out of the IDE, they're now being adopted by enterprises for the first time, and we're starting to see the effects of that. And we believe that every single software company that comes forward is going to end up having a playbook that has to include this AI, data, decision-making, and execution software or domain software layer. We think enterprises are going to have a whole new architecture centered around the use of data science. And we think that startups, which we've been talking about for the past half hour, are going to go through this process of being built now in a very different way than they were built even in the cloud era just 15 years ago. And we're just seeing the start of it. And this is going to be implemented by a risk curve of whether things are AI enhanced, whether things are AI centric to replace human tasks, or whether things will be AI augmented, which means they'll go beyond what humans can do today, and when will society accept that technology to start to use it. So with that, thank you very much for your time.
We have a couple of minutes. Actually, I'd be interested in having you say a little bit more about the winner take most, and whether you see what's the balance between big companies like Google that have access to all sorts of kinds of data from lots of different sources versus some of these startups that can get the data right within particular areas, and how do you see that shaking out in terms of who's going to win and how many companies are going to be in each of these areas?
So I think that, so first of all, startups are really good at verticals and not good at horizontal. The horizontal layer is going to be taken by the cloud players, which we talked about. They're just going up the stack. They're taking over the base platform. They're adding more and more AI services. But they want to be a horizontal platform. They're not going to look at the domain knowledge that you need to be able to do certain disciplines. And that's where startups can play. And then the question is the domain knowledge-based systems, whether they're line of businesses or whether they're vertical industries, are they going to be done by startups in this way, or are they going to be done by big companies and industries? I believe there's a huge advantage to the startups, not just because of new technology starting and a clean slate, but because other big companies in that industry will trust them to be able to have those data rights and that machine-generated data, which I think off the get-go, they're not going to be willing to let their competitors have access to. So this is a huge advantage time for startups to do vertical applications because of the data advantage involved.
And say more about the first. Why don't the horizontal players also go after some of the vertical?
For the most part, it's not in their bailiwick to have the domain experts they would use. What's more likely to happen, Eric, is I think that there will be consulting houses that want to try to build apps on top of these services and try to do this. That's been done in every era, and for the most part, that hasn't succeeded. I mean, there were a lot of consulting firms that wanted to create CRM companies. None of them succeeded. They all ended up doing one-off consulting. So I think that'll be the competitive pressure. These startups will be consulting firms with domain knowledge that sit on top of these systems.
Right. Well, I'm afraid we're out of time. Thanks very much again. And let me just give you everyone a heads up that the next speaker is going to be Alex Pesakovich. He's from Facebook, a scientist there, and he's going to be talking about deep game theory, kind of combining deep learning with some game theory. That'll be on September 20th, in 2 weeks. So see you all then.